Okay, let's solve this equation that involves a double angle. We've got a sine of 2 theta in here. So we're going to have to go around the circle twice now. So let's isolate the trig function, move the 1 over, divide 2. Sine of 2 theta will equal 1/2. So I want to know where does sine equal 1/2. Forget about the 2 for a minute. So we know sine is positive in quadrants 1 and 2. Sine equals 1/2 at a 30-degree reference angle, so this is pi over 6 and 5 pi over 6. So 2 theta then, the inside might equal pi over 6, 5 pi over 6. But because I have this 2 there, I have to go around the circle twice to catch all of my possible solutions. That's only once. So that was going here, then going here. Now I have to go all the way around 2 pi plus an additional pi over 6. So my next guy is going to be pi over 6 plus 2 pi. 2 pi is 12 pi over 6. Our life's going to be easier if we have a common denominator. So my next time that sine equals 1/2 will be at 13 pi over 6. And then the next time would be, if I go all the way around, 12 pi over 6 plus 5 more, 17 pi over 6. Then nobody asked me for 2 theta, I want theta, so divide everybody by 2. How do you divide a fraction by 2? By multiplying by 1/2. Double the denominator. These will be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Those are all the solutions that are between 0 and 2 pi. Every one of these answers lives between 0 and 2 pi because we went around twice, but then we cut them in half. So these are all the solutions. If the question said, don't tell me all the infinite number of solutions, give all the solutions that live in this domain, 0 to 2 pi. There you go, there they are. If I want all the solutions, then I have to play the same game I've always played and say plus 2k pi. They're all infinite number of solutions. Okay. Now another way to approach this, and we'll get the same answer, it'll just look different, is at this step right here. Instead of playing this go around the circle twice game, find the solutions that live in the first revolution. So I got up to this step, and we kind of reverse the order here. I add on the plus 2k pi early. I only go around once and stick on my 2k pi. Then divide everybody by 2. So I get pi over 12, 5 pi over 12, plus dividing everybody by 2 here, plus k pi. This still generates all the same solutions. For example, if I let k equal 1, so when k equals 1, I'm going to take this guy plus pi. Pi would be 6 pi over 6. So 1 pi over 12 plus, I guess we need pi over 12s here. 1 pi over 12 plus 12 pi over 12. My next one would be 13 pi over 12. 5 pi over 12 plus 12 pi over 12 would be 17 pi over 12. We're going to end up with all the same solutions. So this still generates the same set of solutions. If the question said give me all the solutions between 0 and 2 pi, then I've only got half of them. I have to play this game to get the other ones. That's why I like the first method better. But this one's less work. if you want all the solutions. Okay, let's do another one. Let's do one with a 3, where we have to go around 3 times. So let's say cosine of 3 theta equals root 3 over 2. Okay, so where does cosine equal root 3 over 2? Cosine is positive in quadrants 1 and 4. Cosine equals root 3 over 2 at pi over 6 then, and this angle here is 11 pi over 6. So 3 theta would be pi over 6 and 11 pi over 6. And I have to go around the circle, because I have this 3 times. That's my first time around. That's time number 1. Time number 2, I'm going to add on 2 pi to that. So 2 pi would be 12 pi over 6. So I'm going to take those guys and add on 12 over 6. So my next one would be 13 over 6. That's him plus 12. Him plus 12 would be 23 pi over 6. That's time number 2. And then again, go around, just keep adding 2 pi. My next one would be add 12 more to him, 25 pi over 6, add 12 to him. So that would be what, 35 pi over 6? Then divide everybody by 3. So just multiply all the denominators by 3. Theta will be pi over 18, 11 pi over 18, 13 pi over 18, 23 pi over 18, 25 over 18, and 35 over 18. And then at the end, don't forget the plus 2k pi. So there are all the solutions. All of these are less than 2 pi. Like, you could even check that. 36 over 18 would be 2 pi. That guy is less than 2 pi. So that's one way to do it. If you got a 3 there, go around the circle 3 times. If the question says, give me all the solutions between 0 and 2 pi, that's the way to do it, because there are all your answers. They're right in front of you. If the question doesn't want all infinity of the solutions, find the ones that live between 0 and 2 pi by going around the circle 3 times and then dividing by 3. The other way, the shortcut, is just get that first set, just go around once. So I'm going to cut off and say 3 theta is pi over 6, 11 pi over 6. Put in the plus 2k pi now. Divide by 3 early. Divide everything by 3. Pi over 6, 11 pi over 6, plus 2k pi over 3. This is all the solutions. If the question says find every possible solution, that's it. This will generate all of them. But now, if the question said, give me all the solutions between 0 and 2 pi, I'm not done. I have to do more work now. These are the k equals 0 solutions. I need the k equals 1 solutions and the k equals 2 solutions. So when k equals 1, I need pi over 6 plus k equals 1, 2 pi over 3. 2 pi over 3 would equal 4 pi over 6. So 1 pi over 6 plus 4 more would be Oh, hold on. Something didn't go right there. I forgot to divide everybody by 3. So back up a little bit. We have 3 theta is pi over 6, 11 pi over 6 plus 2k pi. Divide everybody by 3. So theta then is pi over 18, 11 pi over 18 plus 2k pi over 3. And if I wanted to find all the solutions, plug in k equals 0, there are my first two. We're going to have 6 total between 0 and 2 pi. K equals 1, I'll have 2 pi over 3, just 2 times 1 times pi over 3. If I want to turn that into 18s, that's 12 pi over 18. 1 plus 12 would be 13 pi over 18. 11 plus 12, 23 over 18. Then I have to do k equals 2. When k equals 2, this would be 4 pi over 18. 4 pi over 3. Multiply top and bottom by 6. That is 24 over 18. Add this guy and that guy to that. 25 over 18, 35 over 18. There would be all 6 solutions if we wanted all the solutions between 0 and 2 pi.